Okay.
You know I'm eating.
I need everyone looking up front and no talking for just a second. Okay, I know you have that within you. Okay, thinking back to these experiences, we've done tuning forks with GarageBand. We did tuning forks with paper, water, ping pong ball. We also looked at the Rubens tube, the flaming tube that I showed you, and also we did some reading about sounds. Okay, I want you to think back about those experiences. Pick one that was the most powerful in changing or affecting the way you are thinking about sound. Okay? Now, changing doesn't mean that you were wrong and now you're right. It means affected it, or I guess caused it to be different. I don't know what you'd call it, change. But anyway, just a little bit of writing about how your thinking's changed about sound. What experience did that? Okay, raise your hand if you are finished with that. It sounds like people are finished up. No? Okay, with the warm-up? Yep. Okay, so what I'd like to do then is have you guys, maybe just a couple people share what they said. I could take a few people randomly, and then maybe I'll have a couple people volunteer. So if I pull your card, just share something that one of these experiences, and then how that maybe changed your thinking. Stephanie, what did you write about?
Rubens tube.
The Rubens tube? Okay. How did it change your thinking? What?
Because it showed how compressed the sound wave to the brain.
Okay, so you're saying it helped you think about how the air or gas is compressed, or the sound is compressed. Okay? Alright, oh darn, she's not here. Let's see. Roberto, will you share what you were writing down with the class? Did you get a chance to finish? Yeah, will you share what you were talking about with me?
The tuning fork? The tuning fork?
Oh, okay. So you were saying that the tuning fork was something that changed your thinking. Will you tell us, or tell the class, like what you're thinking, or how your thinking changed?
Because when you hear it first, you can hear it loud, but then it's like it goes away for a while, and then when you put in your ears, it's vibrating.
Okay. Were those things that you thought about before the tuning fork, or not? Not as much. Okay. So a little bit about how sound works. Okay, I'm going to do one more from the card. Oh, not here. So how about this? That's bad luck. Maybe it's a sign that we should take a couple volunteers. Anybody want to share that didn't get a chance to share? Yeah.
I think the Rubens tube.
Okay.
Because it didn't explain it clearly how the particle was actually where it was.
Mhm.
And you studied the sound in the tube, so it showed that this part had like where the particles were, the sound. That's like that.
Okay. So, is there any others that want to share? Yeah, Jacob.
About the
Now,
Rubens
here,
tube?
You guys, I want to make sure really quick that everyone's just putting whatever they've got in their hands down, just because it's noisy, and I think it's really hard for others to hear what people are saying. Okay. So, go ahead, Jacob.
I thought the Rubens tube because it showed on how the sound waves moved and that, and the fire got more people into it with it.
Okay. Yeah, that's one of my favorite parts about it. I was drawn to build it, partly because I like stuff like that. So let's see. Jacob, will you share with the class what you thought was something that changed your thinking about sound?
One experience was earlier sound can come in many different waves.
So what was it about some of these activities that made you start to think that?
We really used it on Slinky and that sort of thing.
Okay. Using the Slinky to model the sound waves. Okay. Thank you. Brian, actually, that's funny that
I was
that's
thinking
hard.
about the same thing, the sound waves, because I thought they were moved through the air, and then they
Okay, so previously thinking that they move just through the air versus move the molecules. And you said slinky? Thinking about the slinky? Okay. Would anyone like to volunteer as to share? Alex?
To the Rubik's Cube,
Okay.
because I can see where they're actually on, where all the compression is,
Uh-huh.
where like it's more and less, like how the sound gets through the air, where it pushes through the air.
Okay. So, how many people were? Did anybody else put the Rubens too? That for me, that's one of my favorite things, is because it really kind of shows you something that could we actually see how the particles are arranged? No, we can't. But through this, it gives us a way of getting at that. Right? I agree. I mean, I think that's a pretty neat thing to be able to see. Anyone else want to share something that changed their thinking, maybe? And it could be changed in the way that you just added on to something you already knew. Doesn't mean you had to start in a position where you didn't know and then notice that you knew. And last, okay, last call. Okay, so here's what we're gonna do. If you look at the agenda, what I've got up here is this. It says explaining sound. Today, you guys in your table groups are going to do kind of an activity where we think about these experiences that we've had, and then we use that experience base and like the different evidence that we've seen about sound and how sound works from those experiences, and we try to answer a question about how sound works in regards to two different drums. Okay, so what I've got to do is I want to introduce this idea. Did you see these as you came in? Look at the titles of them, and if you're sitting in this row, turn around so you can see these. I want to talk about it for just a second. Turn around so you're kind of comfortable looking at them. If you look where I'm at right now, can you see, Kevin? Yeah, okay. If you need to slide your chair, you can. We're calling these evidence buckets, or I'm calling them evidence buckets. We had 4 different experiences. Tuning forks without GarageBand, so it was like with the ping pong ball and paper. We had tuning forks with the use of GarageBand, the Rubens tube, and details from our reading, and the slinky ideas of when we use the slinky.
Call the office, please. Ms. Gluckstein.
Now, through these activities, you should, in your mind and in some of your past work, have these pieces of evidence or ideas about sound. We got them listed on each poster. For instance, this one, tuning forks without GarageBand, you got to hear what they sounded like, what they sounded, felt, and looked like when you were buzzing them against paper. Remember the difference in vibrations, or how fast they were vibrating? And then also what they sounded, felt, and looked like when you put them in a cup of water. Okay? I'm going to give back the assignment where you wrote information down about this, and I'm also going to give back that group assignment where you answered questions from the readings. So the reason why this is important to have these up is because you're going to have to use these as ways to explain how sound works. You're going to go back to these and use this evidence that you've gathered to really make a full explanation of your question. The question that I'm talking about is each group will get a sheet that looks sort of like this. Well, one side of the class will get this. One side of the class will get this. There is a difference, and the difference is in the question. You have to do the same kind of explanations. So let's go ahead and look at this one. Your group's going to get this thing, and it says, why do the sound waves from these 2 drums have different pitches? Okay, so that's the basic question you're going to be answering. The hard part, I think, or the challenging part about it is that to answer fully, you need to write about these 2 kind of sub-questions. How the pitch is created by the drum, or how the difference in pitch, but also how the energy causes the difference in pitch. So those are kind of 2 things your answer needs to include. But on this last part, it says to have a complete answer, you must include the following. And the first one on your checklist is evidence and examples from each bucket. So when you're answering this, you're going to go back to that poster and be like, what evidence did we get to help us answer this big question about this drum from, say, the Rubens tube? What did we see there that helps us know about sound? Okay? And you look at the bulleted points and you're like, oh yeah, it did tell me something about the particles and how they're arranged. Like some of you said that you thought about that after seeing that. So for each of those, you have to use an example from each bucket. So you go back to each of those 4 experiences and what you learned. You'll also create a model or a diagram, or model/diagram of the instrument, the air, and the high versus low pitch sound for this question. Okay? So we're working on this for 2 days. You're going to get 2 different styles of paper. What do you expect you would do on this style of paper? Right. This would be like explanation writing. Then the other one is I got enough for each group to have a piece of paper like this. This could be for your drawing of your diagram and model. Okay? I figured that since these are such big lines, I'd give each group 2 pieces of paper and then 1 drawing piece. Okay? So, last thing I wanted to mention, did you guys see this? How many people have used word banks in the past when you've done a little bit of writing or explaining? It's like a little, it's a box with basically different related words that can strengthen the way you're talking about these ideas. We have a little more academic language here, or at least more scientific language about these things that we hear or experience, okay? So you'd be using these words in your explanation. That's the last thing on the checklist, okay? So, what I'm going to do then, ask real quick if anyone has any questions to start with. I know what you'll really need to do is look through the task or the question card here that you'll get at your table, and then you'll really be able to ask some questions. I'm going to be coming around and talking to you, asking you some questions, and then you can ask me if you're unsure of what I'm asking you to do here, okay? So, I'm going to have 1 of these per group, and this side is going to get the question about why do the sounds have different volumes when you hit the drum hard versus soft. And that side of the class is going to get the other question, which is equally important. And this question is, why do the sound waves from these 2 drums have different pitches?
That piece of paper to write on.
This one would vibrate more than that one.
This one has a higher pitch, this one has a lower pitch, so this one would vibrate way more than this one, because this one's lower.
Yeah.
Oh, got it.
So, and that's, I guess, what we put for that. Why do the sound waves from this drum have pitches? Because the sound waves from this drum move faster than the ones, and the faster the sound waves move, the higher the pitch will be.
And this one's vibrations are contained more than the other one. They don't have as much space to move, you know what I mean?
Are we gonna get that paper
So,
to
what's
write on?
that? Yeah. So,
Yeah, I'm going to. What I was thinking is,
and then how the different pitches created by the drums. Well, then we can you can tighten the heads,
Just not hit them as hard.
not hit them as hard.
If you tighten this head, tighten this head really tight, it'll sound exactly, them 2 would be exactly the same. Almost exactly the same. That one will have a little more higher pitch than that one. Not much. But tighten that one way more, way higher pitch.
I think we gotta drop basically the whole tightening of the heads in that. It has nothing to do with what we're doing right now.
Right what I just said. You guys get what I mean, right?
Yeah, I know what you're talking about. Well, they're also snare drums.
No.
So
No.
Snare drum, one's a tom.
That one is a snare?
they're both snares,
No, this one's a snare, this is a tom.
Yeah.
but they both got the little thing underneath
Doesn't
it.
mean that they have a little thing. Oh, my little thing.
I don't know, beads or whatever.
Snare, that's smaller. This one is a tom,
can
or
be
a
a tom.
tom, or a tenor.
But I think the tenors had
Tenors
Yes,
are,
they do.
tenors
Unless
are
you
a
take
little
them
bit-
off.
Tenors are about the same size. And heavier. I don't know why we're getting all into music.
I know. Unless you're talking about our marching tenors.
yeah, that's what I'm thinking.
Oh, you haven't?
Those-
No.
those-
Folger, you haven't seen our marching tenors.
Yeah, I've seen those.
No, you haven't.
Yeah.
Now,
Yeah,
the
yeah.
new way?
Yeah, I saw them when you guys were playing.
They're cool.
Man, no, I forgot.
When you get to the drawing part,
Oh man, I put
don't know
my
how to draw.
paper in the recycling about
I
that.
to draw.
well, I'll show you what I could do. If I were gonna just draw big versus small drum, I might just do.
I just don't know how to like show the vibration.
Think back to these different things. Okay, the first time we used tuning forks without GarageBand, did we know anything about the actual vibrations? No. Okay, so let's look for evidence bucket number 2. Tuning forks with GarageBand.
It's a
What did we learn about
frequency
the sound when we used
and vibration
GarageBand?
of the hertz.
Just in general.
No, the less amount of hertz is
No, I really
just
don't.
loud.
That's really what I hear.
How about,
It's lower.
how about the first time we were using it?
Yeah. The less amount of hertz there is, the lower the sound. So the higher the number of hertz are, the higher pitch the sound is.
So you could do something like this to start.
That one would be
What you
the
wanna
number
think about when you
of
go
waves
to
that.
how do you show sound? Think back to what we were talking about when we were talking about streaming. Okay, that's that last.
The energy waves cause it and
You
pitch.
can also get out your reading at what we're talking about. Okay. What I told you, just hang on there because this will be a little bit of a challenge, but it's definitely something you can definitely.
There are more compressions every second. Something like that.
Because the frequency, of sound waves are increasing. Is that?
You should do symbols.
Right, the smaller drum has a higher pitch because the frequency of the sound waves are increasing.
Number 2.
The smaller drum.
Yeah. Because the frequency of the sound waves are increasing. It has a higher pitch.
Itself is different when it's high volume versus low volume.
Cause like there's like are they springs? Yeah, there's springs right on the bottom. They're like springs, and then the energy, like when you hit it, it spreads throughout the inside of the drum, and it vibrates the springs.
Okay, so if you were to go beyond vibrating, either a snare drum vibrates springs or these kind of tom drums just vibrates the air. But the springs are up against air, right? So think about how the tuning fork vibrated against air.
I don't know.
Well, think about this for a second. What was it that happened to the air when it vibrated against the either tuning fork or against this other side of the drum head? What does that air then do?
They like bunch up together, they're like big old posters and like they compress against each other.
Okay, they being the air particles.
particles.
Yeah. So remember how we were thinking about how there's this compressing and then some stretch apart, some are compressed. What was that we were calling that? Well, in general, that was like a sound wave.
Yeah.
And that, the pitch, like how sharp or how low like the sound is, or the volume is affected by what those waves look like. Do you remember yesterday when we were showing it in the slinky and the air diagrams, how those would be different?
You're gonna have to write that.
I think on here, you guys were starting to think of those ideas and putting down how this high pitch or low pitch look different in the wave, or how the low volume and high volume look different in the wave traveling through the air. So why don't you guys talk amongst your group about that sort of stuff, and this will be, you know, kind of struggle for a little while to decide what you're going to say and how you're going to use this.
Created by how
You guys, to start with, have any questions about it?
Does this make sense?
You want to read it to them and see what they think?
Sounds have different volumes when you hit the drum. This is because if you hit the drum hard, it makes loud noise. It makes loud noise because it makes a strong vibration.
Not really.
Well,
Yeah, it does.
No, because look. Vibration, then
That's
makes
true.
loud noise, it makes loud noise.
Well, she can word it different, but it's
Yeah, I
right
can
though.
word it differently. I mean, answer for it. But we still have to do the other things.
And I think that sounds like a good start. I mean, you guys will take that kind of a start, and then you can think back to those different experiences that you've got, and use those posters. Okay, use those posters to kind of help you think back about yeah. And you can not only add on to the way you worded it and more information, but also when you think about one of the things here, this one, it says a model/diagram of the instrument, the air, and the loud versus quiet volume sound wave. When we were doing this is going to really help you portray what the energy looks like traveling through the air.
Yes, it is.
Whether you choose to show it like a slinky, or whether you choose to show it as air particle. I guess since it says air, you might want to choose the more realistic one. But yeah, and then think about the difference between the volume and how does that look differently in a way. Okay? Good start though. This is good. When you think of the word evidence, what do you think?
What we're throwing about, like stuff they have and try to. Do we have to illustrate what? No, I was
like, okay, so say that again.
So do we have to illustrate what we read in the buckets? Put it on here.
How about this? When I was asking you to use evidence from each bucket, the evidence I'm thinking of is like things you saw, things you measured that make you think that something's true. I guess maybe like we what kind of evidence did you? Okay, think about this: high versus low pitch tuning fork. Okay, when you were in that first situation where you weren't using GarageBand. Okay, one of the things it says is we learned about what they sounded, felt, and looked like when they were buzzing against the paper. When you buzz that low tuning fork compared to the high tuning fork on the paper, what did that allow you to now know about the tuning fork and how it acts when it's a high pitch and versus the low pitch?
So like for the high pitch it vibrates faster than the lower pitch, and the lower pitch just vibrates a bit slower.
Okay, so if I were to say, if I were like make some sort of a claim, I could say, well, I know that a high pitch tuning fork vibrates faster because when I held it against paper, it
Made a higher sound and it vibrated faster too.
yeah. I mean, that's the kind of the way I'm envisioning you guys using.
So we have to
that sort of
illustrate it out.
The illustration here, illustrate in I think one of the senses is just like means like to show how it works. But down here, the part for the drawing was listed here: a model or diagram of the instrument, the air, and the high versus low pitch sound wave. That's what this side of the room's getting. Yours I think says about volume. So yours is like basically the same except for volume.
Okay.
So in your picture, what are you imagining that you'd be showing?
I'm just gonna draw like a drum. It's gonna hit. It's gonna be hit, and then like this. I'm gonna draw like a pulse right there. It's gonna be like large pulse because the volume depends on how big the pulse is. And then if it's soft, it's gonna be small pulse.
Okay. So you're gonna show that pulse with like where you think how are you gonna show the pulse?
It's gonna be like in a small bar, and I'm just gonna color it in.
Okay. So you're gonna use it as like you're gonna show the pulse traveling through what kind of medium? Through air, through slinky?
Slinky.
Okay.
More like slinky.
That's a nice idea. So let's look at this together. You wanna read it, Teresa?
Which one?
This question right here.
Why do the sounds have different volumes when you hit the drums hard versus soft?
Okay. What do you think, Dion? What does that
Because
question
when you
mean
hit
to you?
soft, when you hit soft, it doesn't make as a louder noise, but if you hit it hard, it makes a louder noise.
Yeah. So starting there, would you agree with that? What you said, when you hit it hard, it makes a louder noise.
When you hit it softer, it makes a softer noise.
Softer noise.
Like
Okay.
you can barely hear it.
So what do you think it is about that makes it? Why is it a difference in volume when you hit it hard versus soft? Like, why is that? What is it about either the sound wave or the sound traveling? Is there something there that?
No, because when you hit it soft, it's like you can barely hear it because like it's traveling, but as the sound comes out, it goes quieter. But when you hit it harder, as the sound comes out, it goes slower. Like it comes out, you can hear it, but it goes down from not hearing it as it goes down.
When it's loud?
Yeah.
So, Teresa, if you were to hit a drum really hard, what kind of sound would it make? Loud or soft?
Loud.
Loud, okay. What is it about hitting it hard that makes the sound loud?
It makes it makes a loud beat.
Yeah. Can you think of what it is that makes, like, because it's hitting your ear, right, with a lot of force? What is it that's making it, like, it's so loud, though?
The drums in your ear.
The drums in your ear? Okay, how do the drums get to into your ear?
Wait.
I know what you're saying. You tell me more. So how do the drum noises get into your ear?
Because the drum noise goes inside your ears, and then the drums inside your ear just vibrate.
What's it vibrating? What is the drum noise vibrating? Is it vibrating against something in your ear? You know what that part's called that it's vibrating against? Your eardrum.
Just the eardrum here.
Your eardrum. Isn't that weird that that's the eardrum and you hit it here and that's making a noise?
Yeah, that's how they make the eardrums vibrate.
What makes the eardrum vibrate? The drum? Yeah.
You hit it hard.
What is it? Because, that's not touching your ear, is it? Is the drum touching your ear? No. What's touching your ear?
Just the eardrum.
The eardrum is part of your ear, but what's right up against your eardrum, do you know? A vibration. And the vibration's traveling through the air. Okay. Now, do you remember whenever we talked about little particles of air bouncing into each other?
Yeah.
So the drum has a vibration. What's around the drum right now? Like what's surrounding it? Water? Air? Would you agree? Air is around this?
Yeah.
Okay, so if I hit that drum, wham, and it's, okay, pretend this is a drum. Okay? Not a fancy drum, right? But what's happening to the air on the other side? What's happening to the air here?
It's like coming pushing back.
It's pushing out like this?
Yeah, because your hand's coming out.
Yeah, the paper vibrates, right? And then it vibrates against the air, and the air moves out. So inside the air, if you were to think about the air as little dots, we could think of the air like this. You can't see it, right? Can you see anything in the air right now?
No.
Not unless there's dust, but there's invisible particles in the air like this. Okay?
What's the first question?
Now what if I have something right here and I hit this, and this is flexible? Like what if that's like the drum, and I hit this? What's going to happen to those?
They're gonna move.
They're going to move, right?
Yes.
This one's going to move over, right? This one's going to move over, and this one's going to move over. What's it going to do when it gets to this one?
That's gonna, like, as the more it doubles, the more it's gonna hit harder.
So, say that again?
The more together they hit them, as they come together, the more force it's gonna have.
Okay, so there's an idea. One possibility. What do you think, Teresa?
Like
What's going to happen?
I think if we hit the other one, it's going to go back to the paper.
Okay, so it's going to hit here and then maybe go back?
Yeah.
Okay, so that might be a possibility. But what happens if I
How could it go back if there's like two of them together? Like, as they keep coming closer.
Well, hold on a second. What if I had a couple bouncy balls here on the table and I hit one? What would the others do?
Move.
They would move too, right? So if I hit this
Yeah,
one,
but the other one will go back.
that's true too. So couldn't this one hit this one, and then this one might hit this one?
Yeah.
Yeah.
And then this one might hit this one?
Yeah.
So what can happen is, think about this. If this is the drum, and we have a stick here that hits it, right? This is going to vibrate. This part's going to vibrate. Right here, it's going to bounce back and forth. And these little particles are going to hit each other. Okay? Those are going to keep hitting each other. And Teresa, when I'm talking to you right now, air, this same sort of thing is happening between my mouth and your ear. Because you can hear me, right?
Yeah.
Okay. Now, if we go back to the drum, you want to come back there with me? Come back to the drum real quick? Yeah. Let's go back there real quick and we can check this out, okay?
I'm tired.
Come on. You'll be less tired if you get up. Be right over, okay? So, hey Teresa, you want to be the drummer or you want Dion to be? Okay, Dion, why don't you give that a hit? Okay, hit it again. Okay. So, can you imagine all those invisible particles behind that?
Yes.
Okay, now if I were able to tip this up, or if I could have you put your hand down there, put your hand right underneath here. See if you can get your hand right there, okay? Okay, put it just a little ways away. Can you feel that vibration?
Yeah.
Okay, now if your hands, just barely rest your hand on there. Okay? Can you feel your hand vibrate? Do you see that, Teresa? So, if there's air underneath there and the little particles hit each other, imagine this. That hits those, and those keep hitting each other, and then they get to your eardrum. And then what do the little particles do when they hit your eardrum? They make your eardrum vibrate. That's what you're hearing. So the drum's not getting in your ear itself, right? It's not touching your ear, but it's touching the air that's touching your ear. I'll show you something on the computer here in a minute that will help us maybe with this. You guys feel like that? Sort of? Yeah. You kind of sort of buy into that? Yeah? Alright, so I'll let you go back to your table. You guys can think more about this and maybe draw some. Now this sounds good. It says, let's see, well, the smaller the drum has higher pitch because it is smaller, like the tuning fork experiment, and the smaller it is, the higher the pitch. That was the same relationship there. Now this is the same reason for the bigger drum has the lower pitch. Okay, now taking it from there, if you were to think, what was it about the high-pitched tuning fork and it being small that made it?
Oh, the sound wave.
Okay, let me reform my question. Let's see. Trying to think. How about this? What was the small tuning fork doing that made it have a high pitch?
Vibrating more.
Vibrating more.
I think.
Well, if you think back to when we buzzed it against paper, it was vibrating faster, right? Yeah. So, is there something that its small size has
Faster
that?
vibrating.
Yeah. Why?
Higher pitch.
Why do you think it vibrates faster? Because it's smaller.
Because it doesn't have to go around the whole drum.
Possibly.
Vibrate around the whole thing.
Possibly. No, the other thing I was thinking too is if you think about like the tuning forks, they were shorter length, right? Like think about how flexible they were. Maybe the flexibility.
They weren't so flexible when they were short.
Yeah, they weren't so flexible when they were short. Now you should inspect this. Think about how flexible this drum head is compared to this one. Does it sound tighter? Have you ever messed with these? How you rotate them? Check this out. You keep playing this drum while I do this. Watch. Try this one. Keep doing the same thing. Now I'll tell you this drum, when I turn it clockwise, this screw pushes on this and it tightens it together. So if you keep doing that, tap it again and I'll loosen it. Lower, okay? And it's also now more flexible. So that might have something to do with like how the size and the pitch relate. Now I'm not totally sure, but I'm actually honestly kind of wondering if that's similar.
All about flexibility and
Yeah, you might go up and look at the tuning forks themselves and see.
I noticed that the longer you get touched.
And I think the ideas that you have with the evidence bucket one, that you know there's something different with the tuning fork, partly because you buzzed it against paper or buzzed it in the water and it did different things. And you also saw, possibly, but I think listening to it against paper was the thing for me that made me think like, oh yeah, I can hear it vibrating fast or slow. So yeah, you're on the right track with the way you're using those. Okay.
Are the air particles causing
You're talking
the
about little
flames?
circles of air, right? Little particles of air. When you hit them soft, how are they going to be hitting into each other? Are they going to hit into each other hard, or are they going to hit into each other soft?
Depends how you hit it. If you hit it soft, it will bump into something. If you hit it hard, it will hit it hard.
Okay, so you're saying if I hit the drum hard, those air particles are going to hit each other harder.
Yeah.
And if I hit it soft, they're not going to hit each other as hard. Now, when that sound actually finally gets to your eardrum, if these air particles aren't bumping into each other very hard, are they going to bump into your eardrum very hard? So, what I'm saying, if the air particles, or the little circles,
and the air
aren't hitting each other very hard because it's a soft sound,
of the air
are they going to hit your eardrum with much force or
I was
not
getting
much?
to that.
They're going to hit your eardrum soft or hard?
Soft.
Soft, because they were vibrated and they were hit initially kind of soft.
Because when it hits it, like it'll hit all of them. But like as it keeps going on, as all of them are moving, like it'll slow down. Eventually, slow down, and it'll go in your ear.
It'll go in your ear. Now think about this: if you are close to that drum, is it louder?
Yes.
Why is that? If you think about these things hitting here.
Because when you're close to it, it don't have to travel that far.
Okay. So if you think about those things bumping into each other, they don't have as far to keep bumping.
No.
So when they get to your ear, they still have a lot
They'll
of...
eventually stop bumping.
Yeah, when would they eventually stop bumping?
like as it gets there.
As it gets to your ear? Where do you think that force or where do you think that goes after it hits your eardrum?
I'm not really sure.
Yeah, it's hard to think about that, isn't it? But we've gotten to that point. Okay? Teresa, how do you think about Dion's idea? Have you shared that with her?
What diagram should I draw?
I want you to share with her what you're thinking and show her with your drawing. Okay? I want you to see if you're convinced of what he's thinking, okay? So will you explain to her what you're thinking?
I draw it.
You can draw it and tell her. Do you want to start by saying this and showing her with this? How about this? Scoot over to that chair. And you guys can talk about it and let him explain what he's thinking and see what we think. And that might help you decide what you
Pretty good, pretty good?
Yep. Alright. So
Let's talk about sound.
question.
Yeah, before we were just wondering if we had to use the flames, you know, in the Rubens tube, but like we used it as the flames of the Rubens tube represented. We use that represented, and then the air particles of the drums, sound wave. Like so we put it in. We tied in with the drum.
Okay.
Too. So like, is that how we're supposed to do it?
Yeah, you're supposed to use, I mean, you gained something from seeing the Rubens tube. You gained like an idea of maybe
How the sound or the air particles are compressed.
Okay, so you can, I think if I'm thinking what you're saying.
Like I wrote it down. Like this is something.
Read
Like,
it to me.
Right. 2 sentences. The flames of the Rubens tube represented the air particles of the drum's sound wave. The higher flames represented compression, and the lower flames represented the rarefaction of the wave.
Okay.
Does that sound pretty good?
Yeah, it does. Now, with the one that you guys, where's your question sheet at? I forget which side you guys got. Yeah, the volumes.
Yeah.
Okay, now, when you're thinking about that, which part are you using that to help you explain? How the difference in volume is created, or how the energy wave causes difference in volumes? What are you thinking? Or are you just kind of giving a description of what's happening there?
Yeah, giving the description.
Okay, what I really wanting to do is to take your understanding that you just told me about right there and say, how does that help me know how to explain this? Like, why do the sounds have different volumes when you hit the drum hard versus soft? Now you guys both have an idea of how the particles collide into each other and then the energy travels as these compressions along the air. Now, knowing that, when a drum is struck hard versus soft, how does that affect that wave of energy?
The energy.
Like in terms of like the particle spacing, you gained an idea about how the particles are arranged from the Rubens tube. That's, I think, a good way that you could use that as evidence. You could say, I understand that this is how sound travels through air. Now,
But we have to
when
put the
there's a
volume
higher
in there.
volume, this is what's happening within the wave. What was it that you guys used to simulate a wave with high volume or low volume? What did we manipulate to think about that idea?
Want to say that again?
Was there anything that we used to model the way that a wave travels here in class that helped you? Okay, so the last bucket is details from the reading packets or the Slinky as ideas about this. We talked one way we could move the Slinky. What were we having to do to simulate a high volume?
More energy compressed.
More energy. Okay, and we saw the wave do something certain. You could describe what you saw. But then, if you think about the drummer hitting the drum, when are we having a high energy situation? Hard or soft?
Hard.
When we strike that hard, there's more energy in that wave.
And you can even tell by the ear.
Yeah.
Because the eardrum picks it up as a high pitch.
Yeah. And if you think about this, if you hear a really loud noise, what does it do to your ear?
Hurt it? Like,
it hurts
because of the eardrum.
So much vibration.
There's a lot of force there. Okay? So it could be a lot of vibration, which would be a high-pitched noise, like really vibrating, or it could be a low loud sound that's just like real slow vibration, but it's just like it pushes, and that's when you can blow out your eardrums, is when it's high volume, because there's a lot of energy and a lot of force there. So does that?
Yeah.
Okay.
So you just gotta write how it.
And if you end up wanting to like sketch out your ideas about how you're understanding this stuff, and then put it together as an answer that cover these two things that answer this, that's perfect, because you're getting really good understanding when you're writing this down.
Can we put in about distance as well? Can we put in about distance as well?
If you would like to add that, I think it would make an even better answer. And there's one of those that you could use to say we've got some experience with how sound changes or volume changes over distance.
Because I mean, you can hit it really hard, but you can be really far away. But you can still tell the difference between a high pitch and a low pitch. It's just the distance. And the more that it travels, it kind of fades away. The energy kind of loses it, or kind of transforms it to something else. But it doesn't mean it never existed.
So I'm going to leave you here and move on and see how other groups are going on.